Hello, and thank you for watching this video about the law of conservation of momentum. First, let's review momentum. I like to think of it as how much oomph a moving object has. Momentum is related to an object's mass and velocity. Remember, velocity is speed and direction. So momentum is determined by how massive or heavy an object is, how fast it's moving, and the direction in which it is moving. An object moving in different directions may have a positive or negative momentum. The greater the mass or the velocity is, the higher the momentum. So, very heavy objects, like semi-trucks, have a lot of momentum when they're moving because they have such a high mass. A heavy semi-truck, even when moving slowly, would hit something really hard and cause a lot of damage. When moving at any speed, it has a lot of oomph. Objects that are moving extremely quickly also have a high momentum, such as a bullet shot from a gun at a very high speed. A bullet may be very small and light, but at a very high speed, it can cause a lot of damage. When moving very quickly, it has a lot of oomph. If an object is very massive and very fast, like a very fast-moving truck, the momentum is even higher. The formula for calculating momentum is mass times velocity. It can be written as P equals mv, where P is momentum, m is mass, and v is velocity. If either mass or velocity or both are very high numbers and they're multiplied, it will lead to a very high momentum. Moving objects that are very heavy, very fast, or both have a lot of oomph or momentum. Next, let's go over this word conservation. Conservation is to prevent the waste or loss of something. You are protecting something or preserving something. In physics, conservation is usually talking about principles that state that the total amount of something, like momentum, remains constant or the same. This only happens in a perfect world with no outside forces acting on it. Most of the time in the real world, there are some forces acting on things, like friction, so it doesn't always work out perfectly in real life. But if the world were perfect, this would hold true. So now for the law. The law of conservation of momentum says that in the absence of outside forces, like friction, the total momentum of objects that interact does not change. Momentum is conserved. This law comes into play when we're talking about the collision of objects. The total amount of momentum before a collision is the same as the total amount after the collision. For example, if we were playing pool or billiards, the momentum of a single moving ball will be the same as the total momentum of all of the moving balls after they get hit. Let me show you an example. Let's say this ball on the left is currently moving to the right. Its momentum is 5 kilogram meters per second as it rolls. The ball on the right is not moving, so its momentum is 0. The total momentum in this system right now is 5 plus 0, which is 5. In a perfect world with no other forces acting on these balls, if they collide, the total momentum would still be 5, even after they collide. Watch this. As the left ball rolls, it will collide with the other. In a perfect world, the balls would hit, the left one would stop, and the right one would start moving at the same speed. All of the momentum would be transferred from one ball to the other. So now it has a momentum of 5 kilogram meters per second. The left ball now has no momentum because it stopped moving. So the right ball now has a total momentum of 5 kilogram meters per second. 5 plus 5 is 0. The total momentum was conserved. The total momentum was the same both before and after the collision. That is what the law of conservation of momentum means. Before a collision occurs, whatever the total momentum is will be the same as the total momentum after the collision. Each object may have a different momentum than it did before, but the total will always be the same. Let's try an example problem with these toy cars. Let's say the blue toy car had a momentum of 8 kilogram meters per second. The red toy car has a momentum of 6 kilogram meters per second. According to the law of conservation of momentum, what should the total momentum of the cars be after they collide? Let's think back to what the law of conservation of momentum says. The law of conservation of momentum says that in the absence of outside forces, like friction, the total momentum of objects that interact does not change. In other words, the total amount of momentum before a collision is the same as the total amount after the collision. So in order to figure out the total momentum after the collision, we need to figure out the total momentum before the collision. Luckily, we know the momentum of each toy car, so we just need to add them together. The blue car has a momentum of 8 kilogram meters per second, plus the red car's momentum of 6 kilogram meters per second is equal to 14 kilogram meters per second. That is the total momentum before the collision, and according to the law of conservation of momentum, that also will be the total momentum after the collision. So the total momentum both before and after the collision is 14 kilogram meters per second.